Thank you for tuning in. I'm your host, Justin White. I'm here in the Nostrum booth, PRI 2024, booth 2825. I'm here with Frank and Sam Barros from Nostrum. We want to talk about some of the new products they have here and talk about their new injectors. Anybody that's kind of followed me knows that I've always kind of been against the bigger injectors only because I've had issues in the past, but I feel like these guys are onto something. They seem to be bringing something different to the table. So I just wanted to talk to you guys about that, kind of see how your approach works, where it come from, and maybe go over some of it. So
sounds good. Sure.
Who wants to start?
Sure. Let's start.
Go ahead.
Okay. So interesting thing you said is about how we approach it. So we approach products probably differently than our competitors do. You know, we are the culture of the company. The company was founded at a time when we were doing a lot of research. So we look at things very scientifically. We look at things from a perspective of what is the best way to have efficient combustion, right? So, and fuel delivery is an important aspect of that. And so we today, you know, compared to where we were 10 years ago when we started the company, you know, we have processes and standards that don't exist anywhere else. And so when you ask us what's different about the injector, we can be very specific on what's different with respect to spray patterns and also the electrohydraulic performance of the injector, right? We are looking at the complete experience for a customer. It's not just about making the highest flow rate we can make so you can throw in there and do watt horsepower pulls and stuff like that. You know, we are enthusiasts and we were customers. So we understand what it's like to have a bad experience and have trouble. And so in doing that, you know, we really took that to heart in defining what does it mean to make a product here. And we're taking a look at, you know, we want the car to cold start well. We want to be able to use the car, you know, making 1,300 horsepower, but not being able to use it to go to a Cars and Coffee or bring the kids for a ride in it and have that full experience of in the automotive space of being a real car enthusiast wasn't acceptable for us. We don't make products just for trailer queens, right?
Right. Yep.
And that boils down to the level of detail, the tight specification, and the expectations that we set for ourselves on the products.
Okay. Something that kind of touched base with me a long time ago. I did some testing with some regular injectors, and what I was speaking to you about it yesterday, where I would put the injector in a stock car, stock calibration, put the data that was supplied to me in it, and see where they idled, right? To see plus or minus fuel trim, see where we were. And quite a large portion of them were 20% or more off. Two specifically, which was ID and FID, they were within 5 or less. So I was really impressed with that, which kind of showed me that this data is super critical. What I noticed on the newer DI stuff, at first, I think it was just pounds per hour they were changing. And then they were changing pounds per hour and the 3 modifier tables underneath, but nothing else. And to me, like if I have to put that much data into an injector that I know it matters, but kind of doesn't really give a shit about the cam events, why am I not putting that much data into an injector that is literally, you know, tuned around the camshaft events? And then we saw your data and I was impressed with how much you guys really went into detail, which shows me that there's a lot more coming to this. You said that you guys had tested this on a stock application or as close to stock as possible. And I guess that resonated with me. And I was like, man, I like this approach.
Yeah. Because, and you know, we're selling hardware, but everything else around it is part of the product.
Right.
What the data package, the tuning guide, the installation instructions, all of that is part of the customer experience. Part of our development process is we take all the other variables out that you would have in a really big build car in order to make sure that the accuracy of the data package is great.
Right.
I'll make 2 points to that. So you mentioned injector dynamics, and of course they make the most expensive PFI injectors on the market.
Yes.
But what you're paying for is not just the injector. What you're paying for is the quality of the data and the quality of the batching. And similarly, everything that we make is always tested and batched together, because if you just give the customer a fuel injector and let's say some general idea of how much it flows, we're not going to name any names, but one of our competitors will just give you Q-stat, 1,600 pounds per hour, 100 bar. Now, as the tuner, you have to spend all this time figuring out why are my fuel trims so far off at idle? And then, oh, now I've got a negative fuel trim at high RPM. And as the pressure increases, it's not flowing as much as it's supposed to. Why is it doing that? And your time is money. You can't charge the customer 3 times as much just because his garbage injectors took 3 times longer. But once you start running into these dyno nightmares where you're burning up all this time getting the injectors to work, and then the next car that comes along with the same mods and the same injectors takes just as long because the data you have from the first car doesn't work, you just stop wanting to use those types of injectors because it's not worth your time anymore.
It's a bad experience for everybody all around. Then the complaints come back to the manufacturer, so on and so on.
Yeah.
And we've got a lot of experience in the DA space. Like I said, we've been doing this more than 10 years. So we know from products we made in the past, specifically for the LT platform, how difficult it could be.
Yeah.
Yes.
Right. And so we said, no, this is unacceptable. We can't do this. So there's a lot of changes we made, internal processes, standards, even purchasing the right assets that are custom built for us. And ultimately, the goal was to get single data package for an SKU. That's how accurate we wanted it to be. The data package.
You want to break that down a little better, just so people understand how intensive that actually is?
So I'm going to finish one of the things that Sam had mentioned about batching, right? So the batching standard at multiple points on a dynamic curve for DI injector for our standard is plus or minus 3%. Okay, that is after it passes a whole array of pass-fail quality metrics, which include opening, closing time, minimum pulse width, Pmax, and leak tests. Fine leak, gross leak, leak decay. Then it gets to if it makes it through that, then it goes into batching, and it gets married into a set, and every injector in that set is plus or minus 3% to the average of that set.
Which is typically less than 3%.
Yes, so our spec is 3%, but what we have seen is the actual sets we're shipping out are well below 2%, plus or minus 2%, okay? And that's a function of the manufacturing process and our capabilities of quality control, right? The other reason we do that is because several years ago, we departed on a validation project for EOing a BMW, and we were having a lot of conversations on EOing and things like that. And
EO
CARB
being emission certification.
Yeah,
Okay.
CARB was very open that, if you're going to EO the injector, you can only do it for one tune. And so that means that when you have a manufacturer who makes a DI injector, and like you said, every set of injectors has a different data sheet, forget it, you can't do it, okay? So we embarked on what's called the one-cal strategy. That meant that the data set we were producing, the tuning guide we're producing, every set that comes out for the SKU has got to fit with that, and the fuel trims must be minimal.
Yeah.
Right.
Okay? And we've done it, and it works.
All that as a side note, you mentioned, Frank mentioned factory vehicles. Unmodified vehicles are actually the hardest ones to tune, interestingly enough. Let's say if we take an example where you've got something that has a big cam and it's running E85, it needs a lot more fuel at idle. So the injector's open for a lot longer. So you're in a much more linear region of the injector operation. It's a lot more predictable behavior. So when you're running a factory vehicle on gasoline, it has the lowest possible fuel consumption at idle, and it's the hardest thing for the injector to
So what I said the other day is the hardest thing is running a big injector on a stock engine.
Yeah, exactly.
Right. And especially on, say, pump gas, because if you did the big injector, you probably did it for E85, which the fuel mass at idle is 30%-ish more.
Exactly it.
So it's a lot easier for that injector to function.
Yeah.
Well, that was something I was seeing with another brand, is at idle, didn't matter what I did, didn't matter how low I dropped the DI pressure, which in my opinion, I wasn't sure what the spray pattern even looked like at 1,000 less PSI at idle.
Yeah.
Which bothered me.
Yeah, so that's the result of looking for the biggest injector you can make. And we were guilty of that in the beginning because we thought that your typical customer just wants the biggest injector, right? You've got the guy that he's spending all this money building the engine, he's spending money on upgraded injectors, he might as well just get the biggest one. What we learned was that the trade-off in idle stability and low pulse width drivability in pursuing the biggest injector is just not worth it for 99% of the customers. You got one guy that's gonna need the flow rate, and you've got 100 people that hate the way the car drives at idle or at very low pulse durations.
Yeah.
So now the idea is the biggest injector we can make with predictable, reliable, low pulse duration operation.
And maximum pressure performance.
Yes.
Right. So
Right.
we have to talk about both ends of the spectrum. You have absolutely minimum pulse width, but then you also have Pmax, right? And then that's something that we have to remember, that flow rate of an injector is indirectly proportional to the maximum opening pressure of the injector, right?
Right.
So even if you pump more current in, absolutely you can increase that stroke and you can make it work. But there is a limit. There is a saturation point.
Right.
Yeah.
Well, and I think that a lot of us as enthusiasts are guilty of wanting the bigger injector.
Yeah.
But me as a calibrator, I don't just, I do wide open, obviously, is a big deal. But at the end of the day, people could say whatever they want. You want that car to drive good. You don't want to be in a car that drives like crap. And I know a lot of people will be like, oh, well, the O2s will kind of get it closer. I mean, okay, if that's how you want to handle it, but it's just not me. I want something that I can actually know that it's going to get proper fuel economy. I know that's a weird thing for performance, but it's a thing.
Your left foot has more to say about that.
Something that's gonna idle decent, that you can go, out, take your wife out to, dinner and not get out the car smelling disgusting.
Yeah.
Right. All of that plays into it. So I get where, we would only want to go up to a certain size, but in my experience, it seems like even at the 30% I've seen before, I've had the issues where I just couldn't get the idle right. And I've listened to everything they asked me to try, and I tried and I tried and I tried. And I'm not saying I know everything, but I mean, I feel like I gave it enough effort that I just couldn't figure it out.
It falls into what Sam was talking about. You spent so much time on it, you didn't get the desired results, and it was unpleasant.
Yeah.
It turned me off completely to where, as I told you yesterday, I tell all of my guys, just go port injection. Don't even worry about the injectors anymore.
I will say we have never sold a fuel injector that we didn't test ourselves extensively on a factory unmodified vehicle, dyno, cold start, street drivability.
Yeah.
So when we say you can put these injectors on a factory Corvette and get it to cold start at 0 degrees and idle like factory, it's not because the data tells us that it should. It's because we've done it.
We did it.
We've driven the car and we know that it works.
And we've done it, when we launch an injector, those prototypes have been running in the vehicle for 6 to 10 months. Right. Yeah. We have answered every doubt in our minds.
Right. And you tested it on a factory style vehicle, which I know some people might be like, well, I've got a cam car. And how does that relate? Again, we talked about the low pulse width,
it's easier. You're going to burn more fuel with the cam, so you're going to have a longer pulse duration.
That's what I was trying to get at.
Yes.
Is if you've tested in a factory vehicle, that shows me a lot more confidence than if you did it in a built vehicle.
Yeah, or like you said, E85, right?
Right. So I guess that
it goes back to the data set. So for when we take the LT platform, tuning guides is something we have always done. But now we're starting to move into providing HP tuner templates. So it makes it even easier for you. And it actually error proofs it a little bit for us.
Right.
Because as much as we try to give somebody an Excel file where they just have to cut and paste, sometimes it doesn't go right.
Yeah.
Or sometimes, it's not used 100%. If I give you an HP tuner's template, I know everything that we did is in there.
Yeah, just do a file compare, and then you just copy over what is different.
Well, so you guys do a lot of private label deals too, right?
We do.
So it's not like you guys have just come out with this. This isn't new. You said you've been doing it 10 years, but some big power cars have been running your injectors. I found out from about you guys from Titan Motorsports.
Yeah,
so
we, again, that is a result of our quality control, our engineering expertise, our ability to deliver. There's a lot of benefits for a customer, a contract customer like an AMS or a Honda or a Full Race or a Livernois Motorsports or a Rentec or all of those, right? Is that working with us also brings them a level of expertise that makes their end product much more successful.
right.
Yeah.
So what is a couple of the products that you guys make that might be more not as well known? Because I've seen a lot of different products here. I see pumps, I see adapter brackets. I mean,
Yeah,
you guys aren't like just doing injectors.
No, I mean, this is about the comprehensive solutions we're trying to provide.
Yes.
But what's funny is, you know, people, and we've seen it in posts like, oh, you know, you guys don't even exist in the VR30 platform anymore.
Oh,
and
yeah.
we're like, what are you talking about? Every car
Our
that's running
sales say
AMS
otherwise.
is our
Yeah.
product,
Yeah.
right? You know, so like people are using our product and they probably don't even know that it's our product.
But
Yeah, we spoke about that yesterday.
Yeah.
And going back to the parts count, right? So I think a really good example is a recent product launch that we did in collaboration with Full Race. It's a fuel pump, and the competition sells you a pump and then tells you that you have to use a wrench to manually bend the fuel line in the general direction of the pump, and then hopefully you do it without kinking the line or breaking a weld, and then you just sort of like finagle it into place and tighten it and hope that it works.
Additionally, for the same line, you have to drill out the pulsation damper that's in the line.
Oh,
So-
yeah.
so
And
these
hope
are-
the metal
these-
shavings don't go into your
Yeah, so
pump afterwards.
these are the kind of solutions that we say, no, the success of the potential for failure is very high. We don't want to have a customer have that problem.
Yes.
Right.
And so when we do kits, they're very comprehensive. And it goes back to that we are customers too. And we do the installs before you've ever seen the product. We know what you need. We give you everything you need. Okay? So every bolt you're going to need, every O-ring you're going to need, every adapter you're going to need, every heat shield you might need, every abrasive sleeve that you might need is ready for you when you get it. When we do a high
Sometimes
pressure
with-
tube,
With comprehensive directions.
absolutely comprehensive, like, you know, 20 to 40 page installation instructions with every single step in color.
Well, and that goes
Right.
back to what he was saying about injector dynamics. I hear that a lot. People are like, oh, injector dynamics, they're just Bosch injectors. I'm like, but they're not.
No.
And there's so much more to it that goes on in the background that as a calibrator, I've learned, because injector data is not just a number you toss in the file. And you guys understand that.
Yeah.
Injector data is everything. Everything relates in the tune back to what the injector data is,
And it's
because that's how it
also
calculates everything.
The consistency, right? So as a calibrator,
To make it go back to back to back and run the same
that's
exact.
it. As a calibrator, my dream is I can get that tune file from one car that I can put on another car and it's ready to go. And sometimes some platforms will approach that, but as you get into these off-brand injectors, a lot of times the calibration file that worked on one set of injectors is way off for another one.
I've
So
seen that.
There's
Well,
a lot
I've
of
also
value
seen
in
that on the DI
consistency.
stuff. And we're talking 4 tables they were offering us, and the injector's tuned totally different.
Yeah.
I mean, ID is kind of an inspiration for us.
Yeah.
Right.
And Sam would always bring it up. It says, look, in the PFI world, this is the standard.
Yeah.
It's the gold standard, and this is why. And so for us, it was like, well, how are we going to do that for DI?
That's it.
Yeah.
Right now, it's a
And
lot
we
more
need that.
complex. You know, it's very complex with DI. There's a lot of tables. There's a lot of specialty functions, right? So then finding those tables and making sure the tuning suites have them is other area where we bring value.
Yeah, that's
Right.
that's an interesting background process that very few people are aware of. When we're developing fuel injectors or fuel pumps, we're working directly with the people that make the calibration tool. We're working with Cobb, we're working with Accutech, HP tuners, EFI Live, MHD, boot mode, and we're telling them, listen, the latency table for the fuel pump control solenoid is missing, and this is something that you need to alter. Or you're not providing all of the injector data. We need these tables. And sometimes we'll even get the OEM file and then do all of the background work and tell them, here's where
Add
the
this.
tables are, and this is what we
Right.
need to add.
Yep.
See, that's stuff that I think a lot of people don't realize.
Yeah.
And like I said, once I saw the data sheets, you saw, I was like, this is crazy. This is so much more than anybody else is offering. It's not even comparable.
It's a 7-figure investment in test assets that can provide that data to us that no one else has outside of the OEM world.
100%. That was the same thing that
Yeah.
Tony had mentioned. He's like, you guys don't realize what we've put in to get this data. But I can tell you that I actually just recently did a car. We went from ID 1300s to 1750s. I changed the data. The tune was almost spot on.
Yeah.
I was like, this is so nice.
Yes.
Right.
But again, the DI stuff, it just didn't make sense to me that you could adjust an injector that's so critical and the timing is so precise in 3 tables. It just didn't make sense. So as you could tell, I was obviously very pushed off of it. I'm kind of excited now because I feel like I see another avenue. Something we had just talked about. Some people try to debunk it, but it is what it is. More port means less power. As opposed to having DI. If you can have more DI, you can make more effective power. The more port you have to put in that air track, the less air you can flow, the less power you can make, the power potential.
That's exactly right.
So my car has stock LT4 injectors, and I feel like I'm always going to have to run port, obviously, because of the power level I'm making. But if I can throw your injectors in there and I can add 51% of fuel, right? That's a potential of, probably 4%, 5% of power that I can add to this car.
It's something that a lot of people don't realize, but it's also a bit of a safety issue. I remember when the Helion turbo was being developed for the Coyote engine, the DI-PFI one, at one point a decision was made to go 100% PFI for that one. They just got rid of the DI injectors entirely, and the engine became extremely knock prone because that particular combustion system in that high compression ratio engine needed the charge cooling from DI. And once you do away with it, you have much higher end of compression temperatures, much higher knock propensity.
Then you also have no safety because the ECU can't respond. We can't respond with DI to address any type of...
So something I've noticed when dialing in some of these cars where I'll push the DI a little harder, and obviously I try not to go to the point where the pump might get damaged or something, but I'll get a little hairy with it, and the response rate of the car that I push more DI on is significantly improved versus a car that runs a lot more port. One that I did was a turbocharged ZL1, big single turbo. We could get that car up on the brake, no problem, built the boost, perfect. Somebody had the bright idea to pull the DI injectors out, not me, and ran it solely on port, and we had to add nitrous to the car to get the car to spool the turbo back up.
Interesting.
So I assume I relate that to an efficiency issue.
Well, part of it is you're dealing with an engine that was designed to be direct injected, right? So everything about the shape of the combustion chamber, the compression ratio, the intake ports is optimized for direct injection. When you try to bring in the fuel from port, you end up with a lot of issues that the ECM can't even account for. Just as a really simple example, every PFI engine runs a tau model for wall wetting because some of the fuel that you inject ends up wetting the intake port.
It's puddles.
And
it evaporates.
Correct. And the engine is running off some of that evaporated wall film. That has a huge effect on transient fueling. In a direct injected engine, none of those control tables exist.
I was going to say, there's no transient fueling there.
So your transient fueling is all over the place because you're bringing in fuel from the port and there's just no way to accommodate for that. So we believe in OEM level engineering and working with it, not trying to fudge data or add something that wasn't meant to be there and trying to figure out to make it kind of work.
Right, and more DI, less port. Again, I know we're going to have to run the port. But if we have an option that will allow us to have more DI, that will also help in our torque modeling and things like that. Because yes, we can go in there, make it read higher. You can fudge it a little bit, but if you didn't have to do it as much, it's significantly better, correct?
I'll also add, you would be surprised how much you can make DI only. So as I recall, one of the first platforms we did was the LT engine, and Lingenfelter did 1500.
I think it was 1650,
1650 crank horsepower on their engine dyno, DI only. Now it was a race gas, so obviously
I was gonna say that's a definitely a what do you want to call it? It's petrol based fuel.
Yeah, race gas. I believe it was C16, so leaded race fuel, pure gasoline, no ethanol. Engine dyno, so you wouldn't see that at the wheels, but it goes to show that the upper bound is quite a bit higher than most people would think.
Well, I think that goes a lot to where we talked about injection window, pump timing, things like that, there's a lot of tuners that don't know to mess with that or know how to mess with that. But also, from my standpoint, when I tried to bring the pressure up, something we spoke about yesterday was the injectors that I had seen previously were 30% over an LT1, but the limit was 2175 PSI. In my mind, I don't know the direct calculation, but if I could run 2900 on an LT4, I felt like I was making the same amount of fuel.
You can do the math. It's square root P2 over P1. So
I couldn't. You could. I figured you were gonna.
So if you double the pressure, you get 41% more fuel in theory. But what happens is with, I'm going to say, some of our competition and some relatively low-tech approaches to fuel injector modification. For example, there's a company that just drills an additional hole in the injector. At 100 bar, which is the midpoint of the factory fuel pump in an LT engine, right? It goes to 200 bar. At 100 bar, it might flow 30% more. But at 200 bar, it flows nothing. It will not open at that pressure.
That's what I saw.
And then as you walk back from 200 bar, let's say you're at 180 bar, it's opening, but it's not flowing 30% more anymore because it tapers off.
Yeah.
So your actual gain in fuel capacity is much less than what they tell you it is.
Yeah, and then you have to drop the fuel pressure, and it's happening in other platforms as well. It's a really big injector. Then you have to start dropping the fuel pressure. Now you start dropping the fuel pressure, atomization starts to suffer.
Yep, that's what I was going to say.
You start to have really rich regions. So now your knock threshold starts to come down. You know, that
was something I really liked about seeing the spray pattern on all of your things here. I don't know if y'all can see the table, but
oh yeah.
I mean, the attention to detail here really shows, you know, am I too far? Yeah. The attention to detail really shows that, you know, you guys are paying attention to what's critical. This is critical.
It's critical.
When you go just drill the injector out, you know, I like to say a lot of people like to say, they're like, oh, well, the factory did this, and that was stupid. I'm like, so you're telling me the guys they paid millions of dollars to engineer this were stupid?
Multiple millions.
Doesn't really make a lot of sense, right?
Right.
So I look at that as you guys are coming at it from an OEM standpoint, which again, you confirmed, but I had come to that before I even approached you. As you could tell, I did a little research before.
We have internal standards for how large of a hole we want, how close plumes should be to each other. You know, so we do CFD modeling so that we can see
fluid dynamics.
Yeah,
so
fluid dynamics modeling, so we can see, and we'll actually do like a virtual design of experiment to see where the right position of the holes should be. And then we do prototyping in-house on the EDM machine, and we can do these types of images on the hex cell, and we can kind of play with those, and we do DOEs at experiment level. And usually for a development program, we'll finalize and say, okay, these are the two prototype designs. Let's make prototypes and let's go see what we find in vehicle.
Right, actually testing it.
Yeah, did what we think was going to happen in vehicle, is that what we got, right? And then after we do that, we pick a design and then we production release.
Right, so I mean that feels like that kind of covers a lot of the bases, but I guess how to structure this? What is it that's making these other injectors not open? Is there something different that you guys do for that?
It goes back to what I mentioned earlier. You know, in order for it to be commercially viable in the aftermarket, we have to work to a price point that works for the customer. Okay, we could make a brand new injector, and actually we used to do that for research, but the price point is so high that it's not marketable, it's not commerciable. Right. So it is a business. And, you know, we need to sell products, and we know what a customer is willing to pay for a given flow rate. So we can draw, and we have basically what is the price per flow rate that a customer is willing to pay. And then we have to work backwards for that on what can we do? How do we do that? Okay. And so when you make just a really big injector, okay, because we're working with an injector that is coming from a manufacturer today, whether that be, you know, one of the big tier ones, we are not recreating the electromechanical portion of the injector. So we have no control over the coil in an injector, for example.
Right.
And your ability to open that injector is highly dependent on the point at which that coil is going to saturate. So you can't just simply solve it by pumping in more current. And that means the only thing you can do is you have to know that, okay, if we make the flow rate this much larger, that at some point, like Sam said, it is not going to open. It is not going to open. And so we take that into consideration during development, and we actually designed it into our production asset that we also use for development, that we will pressure sweep an injector, and we will, and actually we do it for production for every single injector, we know exactly what the curve is of when it meets that peak point, and when, as Sam was saying, when it starts to inflect. So now the flow rate is starting to drop. It's still opening, but now at that pressure, the flow rate is dropping, and then at some point it just stops opening. It will not open. There is not enough energy to pull that armature back against the fluid
Why
flowing
is the
at that
injector
pressure.
flow dropping?
So what happens is one of the things that you need to do to get an injector to flow more is internally, you need to make it open more. So inside the injector, there's an electromagnet that acts on an armature that pulls a ball off its seat. And if you pull that ball further away from the seat, now there's more space for fluid to flow. So one of the things that we are able to control when we make an injector is how much it opens. And what Frank was trying to explain is, at some point, if you make that distance too large, the electromagnet just can't pull it open against the pressure. So you run into a situation where at some pressure, you're asking it to open across such a large distance that it just won't do it.
Kind of like a gap in a spark plug.
Yeah,
right?
that's a good
If the
good
gap's too
analogy.
big,
It's a
it
very
just-
good analogy. But the gap is a good analogy because what happens when that spark gap is too big,
Too much
is
resistance.
there comes a boost level at which it misfires. So if you're running a certain gap at 20 pounds of boost and you go to 50 pounds of boost, you may run into a misfire. And it only happens at high pressure because at that cylinder pressure, the gap is too large for the voltage you have from the coil. And then as you narrow the gap, you're able to fire.
Right.
With the injector, just before you get to the point where it no longer opens, it starts to partially open. And that's when you have a
Now I see.
non-linear increase in flow, meaning I went up 200 PSI in field pressure and my flow rate didn't change at all. Or we've even seen right at the very end of the operating curve, you go up in pressure and it flows less. And that's really bad as a tuner because all of a sudden your data makes no sense. You're like, I'm flowing, like I up the pressure and the car is leaning out and you're using your knowledge of how injectors work. And you're saying, well, surely I have more pressure because I have more fuel because I put more pressure in. And you don't realize that the injector you have is not giving you predictable performance.
So as you could tell, that aha moment there.
You've seen it.
It was a set of 65-pound injectors, and I had them running at I think 2750. Because they told me 2175, and I'm a rebel. So I had it about 2750, and it was working. But I was like, man, I almost feel like I could have got the same amount of fuel with an LT4 injector.
Because you could.
Right, because I know what, you do this long enough. You know kind of what power the car's supposed to make. I know what it's running. So I'm like, man, I'm going to get a little hairy with this. I went up to 29, 32, 34, and the car started going leaner.
Yes,
and I'm like, what the hell is this? I'm like, I know there's 600 PSI and I'm putting out less fuel. And that's the point where, again, bad experience. I was like, that's it. Take that shit out. I put LT4s and the car still made the same power.
Now, going back to one of the things that we provide when you buy an injector is we show what the flow versus pressure curve looks like. So there are no surprises. You know what to expect. So that way, if you're operating at 3,000 PSI, you know how much it should be flowing.
Which for the GM application, you guys do the same as factory flow, right? 2,900? That's what you rate your injector at?
The stage 1 is rated at the factory flow. The stage 2 is rated at a little bit below. It's rated at 200 bar. So the LT1 will do 240.
2850?
2850? I think so.
Yeah.
So 50 PSI.
Something like that. Yeah.
That's cool.
Yeah.
So, and I'm sure you've tested that to where we're going to go back to the inconsistency thing. Another set, 30s. As you can tell, I've done this a lot, right? With a set of 30s, I could get it to open at 2750. That was just kind of my go-to number when I wanted to push them a little further. Again, I was told that was damaging the injector. So maybe that's partially it. But it would open, and then a few pulls later, the car would miss. And then it would open, and then it would miss. But those specific injectors were rated at 2,900.
Well, so one of the things that's important to remember is that the fuel pressures you're quoting are averages, right?
Obviously,
So,
yeah.
Well, this is very important because that fuel pump is piston driven.
Yeah.
So if you actually plot the pressure in your rail, it's a sinusoidal pressure curve. Every pump stroke, there's a pressure peak, and then in between pump strokes, there's a pressure drop. So when you think you're running 2750 psi, that's just the middle of that sinusoidal curve.
Right.
Yeah, because the sampling rate on the factory fuel rail pressure sensor is
Super slow.
kind of slow.
Yes.
So we know because we use lab grade pressure
Right.
sensors, and we can see that. So this is a great point. So yes, we test every single injector for Pmax.
Mhm.
But
What,
the spec,
explain PMAX, because you brought it up a few
spec-
times. I just
yeah.
want to make sure people understand that.
So Pmax is what is the maximum opening pressure
Okay.
that the injector. There's actually two. There's max flow at max pressure, and then there's max pressure at the minimum allowable flow. And that goes back to what Sam was saying, is there's the peak of the curve,
Yep.
and then there's the inflection of the curve, and what is acceptable? Where does that have to fall?
Yeah.
Okay. So we test every single one. And where were we going before?
Well, so we test every single one, and when we say the injector flows 200 bar as an example, or 3000
it
psi,
can do 200 bar.
what
Yeah.
we mean is every set can open at least that pressure.
At a commanded pressure.
That's what I was getting
200
at.
bar.
Some
is
of
I
them
assume
may
that
open a
was,
little bit
That
higher.
was it will do this every time
Every
deal.
time.
Yes.
Absolutely.
Where, yes, it
That's right.
probably could go a little higher, but
Yep.
it will work at this.
Correct.
So, and the reason is we are testing it, the spec that we're testing it to is higher than what the rail target is.
Correct.
So we might
Right.
say, okay, this injector, run it at 200 bar, commanded rail pressure, that's the spec. But we're testing it to 300 bar. You understand?
Right.
And actually, we test everything at 350 bar, so we get the full curve.
Because you know you got
5,000
guys like
PSI.
me that are going to be rebels, and we're going to push it because we just don't know no better.
Yeah,
But that's the gap.
Yeah,
That's the gap
right.
that we're adding that tolerance because we know that there's, piston pump, like Sam said, there's a sinusoidal wade
Peaks.
there that you can't see.
Do you have an average? I don't know if it's too specific, but about how far that peak really moves?
it's very vehicle specific.
Yeah.
It depends on some modifications. To give you an example, you've probably noticed that the inlet of the fuel rails has a restriction on it.
I was getting to that because a lot of guys remove that, saying that, oh, well, that's a flow restrictor.
So you get higher pressure pulsations when you get rid of it because it's a pressure.
Yeah, you
damping.
start getting that under the hood from the fuel system,
There
fuel
you
gauge,
go.
and I'm like,
Yeah.
something's not right here.
So
the answer is every engine is different because every fuel rail design is different.
Yeah.
The volume of the rail is dying, and volume in its own is dampening, right?
Well, even
The
on
pressure
GM,
pulsation.
there's 3 different sizes of fuel lines. I've noticed that on the V8s. I think there's 2 different seats and 3 different three different seats, 2 different sizes, something like that.
interesting.
Where the inside of the line is different between models, like LT1, LT4. I don't know what the reason is, but I would assume that's got to have something to do with it because you're trying to pressurize such a small area.
So the difference between the LT1 and LT4 could be the pumps, remember. So the
Right.
displacement of the pumps is different, right? And that pump has to, so we haven't talked about pumps yet, but pumps, a high pressure pump has to fill, the solenoid on a pump has to fill the pumping chamber, but it also has to spill.
Right, and
Which
that's
means
where the
that's to
high
let
frequency
fuel out.
solenoid comes in,
Yeah,
correct?
Right,
Okay.
right. But with a larger displacement pump, it has to spill even more. So the pulsations you might see in the rail could be higher.
Now, is that pulsations on the pressure side, on the high side, or on
High
the
side.
low side?
Well,
Both,
Yeah.
right? Because it's moving fuel from one side to the other.
Is there a downside for the removing of that check valve on the low side coming in?
You're going to get higher pressure pulsations. So I think you really need to have an understanding of whether it's an actual restriction or not.
I don't believe it is. I've tried to test it, but I didn't definitively test it, so I don't want to speak on
it also
that.
depends on what type of low pressure pump you have, how much distance there is. So what you see,
Well, I'm talking about the OE
Yeah.
restrictor deal.
when you take the check valve out of the inlet of the pump.
Right.
So what we have seen is that you can have some rattling of the lines.
Yeah.
We have seen in some applications that it can damage the low pressure pump.
I have
Right.
not seen it to be beneficial to remove the check valve on the inlet. I have
No.
not seen it have any impact at all on performance.
Is there maybe a higher flow option aftermarket
For-
for the guys that think
For
it's a
low
restriction that want to replace it with
So
maybe?
we actually developed a high flow check valve. It's actually a pressure pulsation.
right?
Nobody cares.
Yeah.
Nobody cares.
Do you still have it or no?
Yeah, we have them, but nobody cares. Yeah, it doesn't sell.
Okay, well, V3 guys care.
Get a hold
We
of
actually
us
sold
to
one the
test
other
it.
day, and it was a surprise for the sales team.
Yeah.
Yeah.
Well,
"Whoa, we
hopefully
still have
people
that?"
can understand that, because a lot of V3s with a 4 fuel system, they rattle, and they rattle bad. And this is a Cadillac, so you can't have that.
Yeah.
Yeah.
But you do have an option, so
Yeah.
that would be something that I think people will buy. So if you start picking up on sales,
Oh.
it'd be cool.
All right.
But I think that, I know that sounds so minimal, but like when you're riding a Cadillac and you're hearing, brrrr, you don't like that.
Yeah.
I don't want that.
Right. Yeah.
But so what
Most
about
people just zip tie it.
Yeah, still, we try to be a little, we try to be a little bougie, because it's a Cadillac. But so I guess let's go towards the pumps, because that's another major factor. Because I know you guys work with, I don't want to say it wrong, Standard.
Yeah. So we use it, just like the injectors, we use tier 1 pumps. And our need to enter the pump market actually was spurred from our experience as a pump customer. Okay.
Total solution.
So we had really bad experiences with pumps that were available, because when we entered the market, we started with injectors, and we were like, this isn't going to work. We can't. We have to. If we want to sell the injectors, we got to sell a pump. And so we started doing pumps too. Yeah.
So what is different from your pump versus the larger bored out pumps? Is there a difference in that? Is that a comparable thing? I noticed the AN fitting, which is super awesome. But is there a comparison in flow? And I asked that because I've had the same almost, pretty negative experience with the big bore pumps, to where, one, I've had them leak into the engine. And I don't know what the deal was with that, but it's happened 3 times that I can remember.
Which big bore pump are you talking about?
I didn't want to say that.
Is it that 12 millimeter pump?
Yeah.
I think so.
Okay.
But I've had that leak into the engine. The other issue I've had is, again, testing on a dyno, I was able to make more power with an LT4 pump than I was with the big bore pump.
What pressure did you run at?
That's not the point. The point is, it flows more. It should put out more fuel. Because I was told when I brought this up, as you can tell, I like to go on the back end and say, hey, this is a problem I found. What do you guys have a way to fix this? I don't like the whole blasting people. Not my thing.
Sure.
So when I brought this up, I was told, oh, well, you're not looking at it from a volume aspect. I said, I'm looking at it from this one makes more power, and this pump's supposed to be bigger. Well, it's bigger than an LT1. Great. But I'm putting it on an LT4. Why am I making more power with this LT4 pump than the big bore pump?
So it's a wine and cheese pairing kind of a thing, right? It is what injector are you using with what pump?
LT4 injector.
If you're using a stock LT4 injector, that has a pretty high pressure rating. So if you're using an aftermarket pump where you're required to drop the pressure rating, it goes back to what Sam was trying to explain. You're losing fuel volume.
You're selling a bigger pump that does less than the stock pump.
Unless you have a bigger injector.
Yes.
Okay,
if you have a bigger
is this where I'm
injector-
missing it? That's what I'm
So
asking.
if you have a bigger injector that also has a lower pressure rating, now you have a bigger pump with a bigger injector, even though maybe you're running at 15 bar instead of at 20.
Okay. But is that gonna total mass be more?
He's got to do the math.
So
I'll tell you what I ran it at.
so we don't sell,
3250 versus 2450.
sure. So we don't sell a big bore pump for the LT platform. So for that particular product that you're talking about, we're not a manufacturer for it. So
Right.
I can't comment on that. What I can tell you is that obviously we know how much fuel our pumps and our injectors flow, and we would never bring a product to market unless it had a clear, defined, measurable performance advantage.
Right. Which
Because-
that's what I'm noticing.
Ultimately, our reputation is everything, and if someone could show data that, hey, look, the Nostrum injectors flow less than factory, it would be humiliating. There's just no world in which we'll be okay letting that happen. Now, to answer your question more specifically, though, because it's something I'm very passionate about. So when you're asking about what makes our fuel pumps special, if you will, we actually patented the manufacturing method for our low side damper. we were working with one of the other fuel pump companies very early on as a customer. We're making injectors, we're buying pumps from them, and they had a bolted on assembly for the low pressure, and it just loved to leak. You got four screws.
Hey, how is that going to work with that?
It did for a little while.
Yeah.
And then as the screws backed out from vibration, the O-ring would extrude, and now you've got a gasoline leak under your engine bay.
You also had dissimilar materials, so you had expansion contraction differential and stuff like that. So
we decided the only way to do it was to do it the OEM method. Everything is welded. It's pressure tested afterwards. It flows more than the bolted on assembly as well. So there's a performance advantage there. And I think we can make the claim that this is the best high pressure pump you can buy. But we don't make a 12 millimeter one for the LT market yet.
Okay. So I guess, so what is your pump that you do offer? I stick to the GM stuff because it's what I can relate with. What is the benefit of the pump that you guys offer other than that? I don't know if you can see this, but it's
well, that one.
Oh, this was
that's
not
a BMW pump.
Yeah.
Okay, but typically they have an AN fitting here
Yeah.
instead of just a regular slip line.
Well, that's because that's our universal big bore pump. So that allows us to kind of apply it in multiple places. The big difference with our LT4 pump is the pressure rating.
Right.
You know, it is a true 250 bar commanded rail pressure. You can do it on an LT4 pump, but you're really, really close to the pressure relief valve already on the GM LT4 pump.
Which that's probably stressing the pump beyond
what
it needs to be run at anyways.
When you're really close and you won't maybe see it, but we can see it on bench that the VE starts to drop on the pump.
Right,
Because
kind of
you
like
start
a
to trigger.
turbo.
Let me develop with that a little bit because you keep saying that you like to push the envelope, and I think this will be good information.
Well, don't
for
we
you.
all?
Yes, we do. But
I want to make sure that I'm not getting the results I'm getting because of that. Could I run it at factory pressures and get the same results?
that's what I wanted to talk about with you. So inside the fuel pump, there is a bypass valve that's essentially an emergency spillover when the pressure is too high. If I get a factory LT4 engine and I command 5,000 PSI rail pressure, what's going to happen is it's going to go up to some pressure level, maybe 3,700-ish. And then at that point, the bypass valve opens. The bypass valve is a ball on a spring. So when the pressure is high enough, it pushes the ball down, compresses the spring, and fuel spills over.
Right.
There are two reasons you don't want to push the envelope there. The first reason is right as you're getting there, the ball starts to just simmer and you lose volumetric efficiency. So now your pump is moving less fuel than it otherwise would because some of the fuel is being bypassed. The second reason is if you keep hammering that ball down, you start working the spring, you actually start lowering the maximum pressure of the pump.
Yes.
So when you're pushing the envelope, don't always try and go to the very limit of the pump.
Right.
Try and be mindful of the fact that that bypass valve is really a no-go zone. You do not want to be operating.
It's a safety.
Yes.
Right. Well, and then if you factor in the oscillation, so that's why.
There you go.
Typically, the only time I do this over like 2,900 is something that we're at the track and we're trying to get a number out of it, and we just want that more DI, right?
Yeah.
But 3,250, because in my mind, by testing intake air temp sensors and the latency on those, made me think, hey, if this thing's showing 3,250, it's probably seeing 3,500 a few times. And that's, you guys have confirmed that.
Yeah.
But that's kind of what my mind state was.
Yeah.
And I guess the VE you're talking about is the efficiency of that pump at such pressure, which, like I was saying, relates like a turbo VE map, right?
Yeah.
So at a certain efficiency, it's doing great. But once you get out of that, it's...
So V is how much fuel it flows in relation to how much fuel it should theoretically be flowing.
Yeah.
So if you've got a pump that should move 100 gallons an hour and it's moving 90, then the volumetric efficiency is 90%. At Pmax, it's going to be less, and you want to be just a little bit below Pmax so you're not running into those issues.
Yeah, that VE table, it's indirectly proportional to target pressure and also RPM.
Yeah.
So even if you're not triggering the pressure relief, as you increase pressure, the VE slowly gets worse because you have more slippage.
Yeah.
Okay, so it's not a perfect seal. It's not a zero leak seal between the piston and the pump.
The fuel flows back along the piston.
So there's always some leakage through there. And as you increase pressure and RPM, those losses increase. Now, when you hit the pressure relief, though, it really starts to fall off a cliff. If we drew a 3D map of that, you can definitely see where that's starting to open.
And that, I mean, that makes a lot of sense. I get that 100%. I guess one thing I was kind of curious about, does boost pressure affect your injector flow like it does on, so obviously there's an intake manifold delta, right, for a port injector, but is the direct injector just high enough that it doesn't matter?
So again, it's square root P2 over P1, where your P2, your injector pressure, is 3,000 PSI. Your boost pressure, let's say, is 30 PSI. Does it affect it? Yes. In a meaningful way? Absolutely not.
No, okay.
Now, obviously, if you're running 60 PSI fuel pressure and you have 30 pounds of boost,
Now
it's
you're
a
running 30.
very different
Right.
story.
Yeah.
Okay.
Yeah.
So
That's something I was just curious about. So do you guys make lines too?
We make everything that's necessary.
Oh, you said
to
heat shield,
integrate.
everything.
everything you
Yeah,
need,
everything you
including,
need.
I think this is a really good example of just the level of detail we go to.
I was going to ask about that.
So this is a guide tool. It's
Yeah.
completely unnecessary. We could trust you to line it up and get it right. But with the guide tool, we don't have to. It takes the error
It's
out of the
error-proofing
process.
And we were the first to do this. So now if you look, everybody else is doing it. Right? We started doing this in 2018, 2017. Yeah.
Do you,
Because, and let me explain why. The pump piston, the lash cap of that piston has to touch your follower right in its center.
Yep.
And it's not a flat surface that it's touching. Okay. There is literally like, it's like a ball on a plate. There is one point that it's touching. And if that strays, off center, you start to reduce the life not only of the pump, but of the follower.
well, you start side loading it, right?
But
Yeah,
what's
exactly.
really interesting is this shows up months after
Yeah.
installation.
Right,
So
yeah.
It's one of those things
It
where
just eats it away.
Yeah, and it takes a while, and eventually it ends up being warranty calls, and we don't like warranty calls, so we make things that don't break.
But what about the preload deal? So we have to lash cap our pumps with certain camshafts and things like that. Is that something you guys mess with?
That's in the design.
I was going to
So
say,
when
because I
we're
see you make your
designing-
own base.
When we design the base, we have our minimum spec for preload. So we're always, that's part of the map that we're doing when we're on that.
Well, that's something that I see a lot of people, they'll talk bad about a pump, but what they don't realize is they didn't set their preload and it smashed the piston and it locks the pump up.
Yeah, or the opposite is it's not in full contact, it's not preloaded, and then the actual flow rate they see on the pump is below what it should be.
Right, because you're coming off of it, correct?
Yes, exactly. It's
Okay.
floating away.
Okay. I think that's a lot of things that a lot of people don't, you would think they know, but you can't just assume.
Yeah.
So what's the future? What are you guys looking, is there anything kind of in the works that you guys are really looking to get into, or?
So we believe in supporting whatever platforms the aftermarket is most interested in. We have excellent relationships with all of the calibration companies, as well as all the big companies in the aftermarket. I think it's a fair statement to say that if a vehicle is popular in the aftermarket and has good quality parts to increase its performance, we will most likely end up making a fuel system for it.
Okay.
If we're looking at what technologies the OEs have implemented and how we're going to get into that, we have spent years working on the new 350 bar systems because it's a lot higher pressure and it's a different level of technology than we were making before. And so we have been testing those products for years to make sure that the product and also our assets, all of our equipment for quality control and manufacturing are in order. So we're going to see that start coming to light next year.
Isn't that what BMW runs, 5,000 PSI?
Most newer cars are running 5,000 PSI now.
Yeah.
So are you
BMW,
talking
the
about
new
trying to move that
Volkswagens.
into like,
No, just support that with
Yeah,
aftermarket.
supporting
support what
with
they
those
have?
products.
Okay,
Yeah.
okay.
Yeah.
Is there a stage 3 injector in the pipeline for GM?
For the LT4,
Or are we pretty much
for the
maxed out
LT1,
efficiently?
LT4, it is unlikely we'll do that. I mean, that's
Right.
a stage 2 will do 1,400 horsepower.
On gas?
Yeah.
Right.
Right. We are really shifting into the 6mm stem products for the LT2. We actually had an LT2 stage 1 product last year at this time, and it just didn't seem to gain a lot of traction. But this year, it's gained a lot of traction.
So you bring that up. Another thing, we spoke about it yesterday, but a lot of people don't know. I only know because GPI had posted it, but the injector nozzle, right? The diameter is different.
Stem.
The stem. Okay.
Yeah.
I didn't know.
Yeah, the stem, the pintle shaft, is 6 millimeters and not 7.5. And up to this point in time, most manufacturers have been drilling out the cylinder heads in order to do that. But now I think that there's enough LT2s, C8s, Escalades that are out there that, it doesn't require, they don't want to have to take apart the cylinder head. They don't have to take apart the engine, right? They want to be able to, I think the presence of turbocharger kits is starting to become a lot more popular as opposed to supercharger kits.
Right.
And so for the LT2, we think that that's going to be, more
So you're
successful.
making the smaller pintle
6
injectors.
millimeter. Yeah. Right.
Okay.
Yep.
Which that seems like a much better deal than having to drill out the cylinder heads.
Is anyone doing that?
I don't know. That's what he said.
Yes, they are doing that. We have customers that are doing that today.
Seems a hair wild.
Because they're already taking the engines apart,
Oh, okay. Yeah.
right? So if they're already taking the engine apart, then sure, why not?
Sure, you're already
right?
porting the heads.
Yeah,
What's
exactly.
another machining operation at that point?
Exactly.
Sure.
Exactly. Right. But that's what I'm saying is bolt-on turbo kits for the C8 and, aftermarket support for the C8 has probably reached a point now where you don't have to take the engine apart.
Yeah.
We now know how strong a C8 long block is, so we know what it can do.
Mhm.
And so, what's that answer? And that has been a lot of the feedback this week here at PRI 2024 about LT2. Yeah. So we're real happy about that because we're ready for that. We're well positioned. for that.
Okay. Yeah, and I think that's gonna be a big market. I think especially the flat plane crank motor, it's gonna be a monster
Oh, that definitely.
if we can access it.
Yeah.
If we can access it, I think it's gonna
that's
be
what I was-
it's gonna
I
be an
am
animal.
very excited to see what it's going to do.
Yeah.
So it seems like GM's even excited, which is weird, and I like it. So, but I know you got places to go. I appreciate your time. Thank you guys for making time for me.
Thank you very much.
It was definitely an eye opener, and I'll definitely be in talks with you
Absolutely.
about trying these out because I'm excited for what it'll hold. I'm excited for what our next level, right? So where can people find the injectors? Where do we go to find you guys?
So nostrumshop.com, that's the e-commerce website. You can also go to any of our retailers, the contract customers that we talked about, whether that be Ligenfelter for the LT platform, or AMS for the Infinity Nissan platforms, or Honda for the Type R, Type S.
And the Ford Explorer injectors.
For Explorer, you just come to us.
Yeah. Okay. Yeah.
Yeah.
All right. Well, thank you guys. I really
Thank you
appreciate
very
it.
much.
Yep. Thank you very much.
And that's a wrap.